Let's get this lesson on trigonometry started with a great joke. What type of math do trees do? Of course, trigonometry. All right, not only can we use our calculators to give an angle to find a ratio, like for example, the sine of 45 equals, we can ask the calculator what angle gives us any given ratio. So for example, let's pretend for a minute that we didn't know what angle gave us 0.707. So on our calculator, we have to find the shift or the second function button, and then we have to make sure that when we enter it, we get this little notation here, the -1, sine -1, and we enter in as many values of our ratio as we can, the better. And then we hit enter, and notice how it gives us 44.9. So it's very close to 45 degrees, and that's just because I didn't put in all the decimal places. So using second function will give you the angle given the ratio. This is a very helpful function to know how to use. Let's have a look at the sine curve. So if we're plugging in any angle, that's a sine ratio, using the two sides opposite over hypotenuse. This is the graph that your calculator has inside its little brain. So if you want to know what the sine of 0 is, well, the sine of 0 is 0. Well, let's say, what is the sine of 90? The sine of 90 is 1. What is the sine of 180? 0. What is the sine of 270? -1. And what is the sine of 360? 0. So as you can see, a couple things are happening. Pretty important things are happening. We have positive values on the top side, and we have negative values on the bottom. But if you have a look and notice, the top of this starts at 1 and it goes to -1. So the only values we're going to have for sine are between 1 and -1. From 0 to 180 degrees, those are going to be positive. And from 180 to 360, those values will be negative. So you can use this curve to estimate the sine value of any angle. So for example, if you want to estimate the sine value of 50 degrees, we go to 50, we go up, we go across. I'm going to guess it's about 0.75. So you can go ahead and check that on the calculator, sine 50 equals, and see if I'm close. Well, let's see if we can do the sine of 100. So the sine of 100 is just less than 1, so I'm going to be optimistic and say about 0.98. So go ahead and put in sine 100 and see if I'm close. We can also estimate values on the negative side. So for example, if I want to estimate the value of the sine of 200, well, 200 is around, I'm going to go with negative 0.35. So again, you can plug in the sine of 200 and see what you get. The nice thing about this graph is you can also go backwards. So this is exciting. We can go to a value and say, give me a value for sine that is about a half. Okay, so here's a half, and then here's this. So that's about 30 degrees. So you can check that. How you check that on your calculator is you do second function sine. So second function sine, or shift sine of 0.5. Your calculator is going to give you the first value on the graph, and then we'd have to calculate the distance between those 2 points for our second value, but for now, that will get you started. We'll talk more about second function later. All right, here's the cosine curve. If you notice, the curves look similar. These are essentially the same curve with what we call a phase shift. The graph's been moved over a little bit to the left or to the right to get the second graph. So let's play the same game. Well, what is the cosine of 0? Well, the cosine of 0 is 1. These should actually go up in 90s. So this is the cosine of 90 is 0. 180 is -1 right to the bottom. This is 280 is 0, and 360 is at 1. So you can do estimations from here as well. So let's estimate what is the sine of 50, or sorry, the cosine of 50 degrees is about 0.6, I would give it. Let's do some of the negative values. So the cosine of 150, oh, that's going to be negative maybe 0.89. So you can check that on your calculator. And this side is positive again. So the cosine of 300 degrees looks like it's at exactly 0.5. Again, look at the highs, 1 and -1. And the middle line here is 0. So from here you can see that the values of cosine again go as high as 1 as low as -1, and this time we have positive at the ends and negatives in the middle. So you will get positive and negative numbers from 0 to -1 for cosine. A lot of students ask me why I don't talk to them about the tangent curve, because the tangent curve has a lot of problems. One, it's not a continuous graph, and two, you have to know about restrictions, and it's not as easy to do predictions from this graph, although you can see that there are some values that we could find. So generally speaking, when we're using our estimation tools for trigonometry, we generally only use sine and cos graphs, but one thing that I always talk about is we can use the ratio of tan theta is equal to sine theta over cos theta, which means that if we're estimating, for example, the tangent of 65 degrees, if we find an estimate for the sine of 65 and the cos of 65 and divide them, that will give us a pretty close value to tangent. So if you want to try that for tangent, go right ahead. Alright, let's start by trying to solve an actual problem. So a lot of trigonometry problems have to do with simple things like ladders and walls, or ramps and stairwells, different kind of things where objects are leaning against other objects. So let's have a look at this question. Suppose it says a ladder that is 9 meters long is leaning up against a wall, and it's leaning at an angle where the ladder hits the ground at 27 degrees. The question is how far up the wall does the ladder hit? So you have to try to visualize a building here, a little bit of a building, and this is your ladder here. So better diagrams often help. So from our reference angle, we know it's 27 degrees. So what we're going to start looking at is the basics of trigonometry. From this reference angle, what sides do we have? Well, let's have a look. From here, from our 27, if we go over here, you think ahead of me, I'll just put them there. You got it. You got it right if you picked opposite for the wall and the ladder represents a hypotenuse. So, going back to basics, we have to ask ourselves, what ratio uses opposite and the hypotenuse? Well, we know the first ratio uses that. So it's the sine, in this case of 27 degrees, equals the opposite. But remember, we don't know what the opposite is, so we could call that x. And we know that the ladder is 9 units, could be 9 feet, 9 meters high. So now we have to solve for our unknown. So if we apply basic algebra and we multiply both sides by 9, we now get x is equal to 9 times the value of the sine of 27 degrees. So a couple ways you could do this. You could do, depending on your calculator, sine of 27 equals times 9. And you could use an estimation from the table or from the chart or the graph we talked about earlier. And I apologize, I've forgotten my calculator, so I will stop this while I go get it. Alright, as you can see, I punched in 9 sine of 27 and it equals 4.0859. So what that means is the ladder reaches about 4 units or 4 feet or 4 meters up the wall. So we've now done our first trig problem. Alright, let's have a look at another problem. Again, keep in mind that all trigonometry problems are in the context of a ladder or a ramp or maybe a book leaning up against a shelf. So that will be the context of the problem. So once you have the diagram drawn, we start by the reference angle. So here we have the reference angle is 53 degrees. Now we have two sides, an 8 and a y. So the first thing we have to do is always figure out what's what. Well, the 8 is beside the angle, so it's your adjacent, and the y is on the longest side, so that's your hypotenuse, and there's nothing on the opposite, and that's okay. So going back to our basics, what do we know about a and h? Well, a and h have to do with the ratio cosine. The cosine of 53 degrees is equal to 8 over our unknown hypotenuse. Now, notice, if you will, that the cosine of 53 is equal to 8 over y is in a different form than the first question. Our unknown value is now missing on the bottom. So there's a few ways that we could solve for this, and we can do this in a two-step problem. So the first way is, let's move the y to the other side. So multiply both sides by y. So you get y cos of 53 degrees equals 8. And now we have to divide both sides by cos 53. So y is equal to 8 divided by the cos of 53 degrees. Now, In a very unmathy kind of way, I call this switcheroo. Because if you notice, the y is now where the cos 53 is, and the cos 53 is now where the y is. So when the missing piece is on the bottom, in the denominator, which starts with d, we do the operation division. All right, let's see what we get. All right, and if you plug that into your calculator and you do 8 divided by cos of 53, you get 13.29. So let's always leave our answers at 2 decimal places. And so now we know the length of the hypotenuse, 13.29 units. All right, let's look at the third type of question for trigonometry. The first two are missing sides, depending on where they were located in the ratio, and the third side is a missing angle. Now, first steps we always start with. We start with the basics. We look at our reference angle. In this case, our reference angle is z. It's an unknown value. So from z, we label our sides. So we can move our opposite here and our adjacent here. So now we have opposite and adjacent, so we have the ratio tangent. So from here we can fill in the missing information. The tangent of z is equal to opposite over adjacent, which is 6 over 15. Now, in previous discussions, we had looked at how to go from the angle to the ratio. Now, this is how to go from the ratio to the angle. So in this case, we will use our second function, tangent, or shift tan, and it should look like this in your calculator. And this operation will give you the angle size. All right, have a look. If you put in tan second function, you'll get the -1 notation. 6 divided by 15, you get 21.80 degrees. So that means the angle for our reference angle Z is equal to 21.8 degrees. All right, thanks for watching this really long video about trigonometry, but this is essentially all the information you need to know for grade 10 trigonometry. Step 1, don't forget to label the sides. Step 2, pick your ratio. Step 3, write out your ratio with all the parts, the name of the ratio, the angle, the equal sign, and the value. And the third part is to solve for missing pieces, maybe a missing side or a missing angle. With these basic tools, you're now able to progress to our next video, which will be on solving trigonometry word problems, when you're given the word problems and you have to draw the diagram, or when you have 2 or more triangles involved in the problem. So, I hope you enjoyed this trigonometry video.